Hi folks, thanks for watching. This is a little follow-up video to the video I made 2 days ago about how to use ZX to create and run and distribute and deploy GUI applications in the Erlang programming language. In using ZX so that lay users, people that are not engineers, can run it. I also showed uh, the GUI interface to ZX, which is called Vapor. Uh, that's a GUI launcher. It lists programs that your system can see that are available to it, and you can click them and they just run. So I did that video. Excuse me. I did that video on Linux, and everything on Linux works, and it's just snappy. It's quite crisp. On Windows, the experience is a little bit different. Uh, So I'm going to show you how that works, starting from the same point that we started on the Linux one. Erlang 23 is installed on this. We can go to the ZX download thing, download site, and then Windows, right? So install Vapor exe, which I've just downloaded, so it's in my downloads folder. And I'll go ahead and run this. And yes, run that, please. So that's the installer. There's not much to, I mean, there's not much to Vapor and ZX. Erlang's the bigger part. So this little window, Vapor, the icon here, I don't have a cool icon for Vapor yet. When I think of something cool, I guess I'll put it on there. So anyway, this happens now. Blah. Oh, I see. Okay, so there's a newer version, so it's updating itself on start. So, don't need that anymore. So what just happened is I clicked Vapor and then this window opens and then this opens. Like this is the one that we wanted, right? We wanted this guy. We don't really care about this guy. Uh, it's a curiosity that may be interesting to developers who want to see what's going on or just curious users or whatever, but this isn't really something that we want. Uh, like this would be better. Um, you know, so that's kind of strange. Uh, the reason for this, we'll talk about this in a second. Real quick, just running the examples that I showed yesterday or the other day were Minesweeper and Barnes' Fern. Those are like the two main. This was sort of a tutorial project. That's why the website for this is actually just a blog page. Minesweeper and Barnsley's Fern. If we click Minesweeper, this works exactly the same way that the Linux interface does. You can pick a version, and it defaults to the latest. So, and this is exactly what we would expect to see from a Minesweeper game. Now, when we close the target application down, the runtime shuts down just like it does on Linux. The difference is we have this like terminal window that's just there. So if we pick this to run again, of course, just like on Linux, the code's already been built and it's cached, so it just pops up immediately. It's nice. For large programs, that's actually a significant burden because compilation on Windows takes longer for some reason. Um, okay, what we just saw up in this corner. Sometimes it's faster than other times, but let's look at Barnsley's Fern just for fun. Just do a ton of iterations. 100,000 iterations gives us that. That's actually pretty cool. So when I open Vapor, pay attention to the upper left corner. On Linux, when I run it, it just pops up, bam, right? When I run it here, we're going to see all the objects populate before they actually should be shown. On Linux, we can avoid that by using the wx batch function, where the argument to wx batch is a function, and any steps in there that might update the GUI, any kind of wx stuff, the wx server is supposed to be suspended while batch is running, and that allows you to hide any messiness before you've finished the frame and want to show it to people. Most frames, of course, they build so fast that you can't see anything anyway. What was happening with this one is that Vapor's making a request to a Zomp server, pulling information into, it's doing the equivalent of the like ZX describe, ZX describe and then package name, and you get the metadata for the packages formatted for you. That's what this is here. Minesweeper, description, author, package, repo, right? That stuff has to come in from the Zomp server, whichever one we're connected to right now. So as it's getting that data, it's building these, has a list of metadata, and it's going to build a field for each one of these, and then put it into this scrolling area. As it's building those, that we see each element kind of pop up parentless in the upper left corner of the window. It's not a big deal, but it's, there's two categories of Windows software, and they're quite extreme in how different they are. On the one hand, you've got games and like media specific applications, like movie players and stuff like that, and games. And there's a lot of crossover in that area. That media focused stuff, especially games, they don't use Windows widgets for the most part. They don't care about .NET and COM and all that. Most of that stuff is never called from most game software. Most game libraries, they have their own widget library internal to themselves. They just want to take the screen over, do everything their own way, so they can guarantee that it is absolutely flawless. Well, bugs in games are notorious and famous, but the ability, the absolute freedom that you have when you build your own widget set from scratch is immense, and you want to be able to do things that you can't do with a typical desktop widget set. Your goal isn't to make a button that someone clicks. Your goal is to make a special gesture with the mouse and keyboard that is interpreted in a certain way and then displayed as, a wizard's mana level goes up and down and an orb glows a different color as in reaction to that, or some like very unique interface idea. Or maybe you want a 3D world and you have clickables, but those clickables are in the 3D world. Of course, that's not what a desktop widget set provides for you. So when you write games, you go, all the way to the extreme of writing your own interface set, all of your own every peripheral interaction from the computer. You accept all those events and react to them to make your gameplay work the way that you want. So that's one extreme over here. The opposite end of the spectrum is using desktop widgets and language built-ins and GUI bindings and so on to get the desktop manager to build interfaces that you want so that users can do things in kind of a simple, clicky way. And most of that software is for business, research, or school. It's they're almost always like some kind of data management application of one form or another. And people have to use those applications for work or for school. And those applications they're so ugly, they're so famous for being ugly that we don't even think about them. We don't even evaluate them in terms of how nice they're how nice looking they are. Now for people that have been working on, you know, really nice desktops on Linux and OS 10, and um, a KDE user might say that OS 10's like terrible or a weird experience or ugly, and it's really not, right? OS 10 is great, like it's really great. KDE is really great. Unity, which I don't like at all, but it's actually pretty great. Um, I don't remember the last time I saw a poorly adjusted color palette or a non like unaliased an unanti-aliased font, um, or whatever. Like in that world, everything is nice. Everything's super nice. Uh, the number of quirks in the systems when you're using GUI applications over on that side, uh, you just don't. I mean, a lot of open source authors kind of obsess about how things look, and people aren't paying them money, right? And there's alternatives, so you have to look pretty good. Um, you look at applications like GIMP and Krita and Inkscape and so on, and it's pretty pretty nice stuff over there. Um, you come back to Windows, and I mean, look at these fonts. They're awful. Now I can probably pick something to make that better, but just look at the default font here. Uh, Remember the downloads folder? Like, this is terrible. I know this is Japanese, and I hope it looks better in English. Um, but like, these fonts are awful, and I'm not a big picky guy about fonts, but after you get used to, a very handsomely done system, and you come over here, I mean, this is pretty bad. I feel like it's like 1992 all over again. And you go look in any office where people they have to use Windows for work because they've got programs that are Windows specific. This ugly, weird stuff is invisible to them. Um, so, you know, again, you got two extremes: video games where people are super picky about appearance. Then you have just manage data and get work done software. And that software in the Windows world is like hideous. Uh, so, in that context, I, in sort of an unstructured way, started pointing out some things here about the way the Vapor runs on Windows compared to the way it runs on Linux. And the fonts aren't pretty. I can probably manage that and fix it. I can probably find a way to make the updates to the uh, widget objects as they come in work a little bit nicer. Um, but there's a couple things I cannot do. One of them is this window right here. Uh, this window has to pop up. Now, the launcher for Vapor is actually written in Rust, and it's written in a way that doesn't have to show a window like this. But the Erlang runtime always forces one of these windows open. The reason is because the Erlang runtime was built in such a way that forces a, a terminal window to open. Now, that's just a build option. Like, I think Erlang Solutions is the one that made this Erlang installer, and I'm really glad that they did because it's great that we have that. Um, the only weird part, I guess the only two weird parts is one, Erlang starts up a lot slower on Windows, and Windows is probably to blame for at least some of that. Uh, I mean, logging into Windows takes forever for some reason compared to a lot of other systems. So I don't know. Um, the Erlang startup time's a little bit slow. It's manageable though. Again, if you're writing utility applications that are useful, that people need to get work done, writing useful things for people on Windows users they're like trained to accept ugly, slow garbage, uh, and they'll just take it. Gamers won't, but for work and school, it's like people's minds go in a different mode, and they're fine with it. So the startup times are not really that big of a deal. Uh, a lot of small business software, utility software, um, scripts that like are helpful for people, uh, wind up doing stuff like this, where this terminal window pops open. It has no useful information really. Uh, it's just like there. a lot of uh, a lot of startup scripts that have this that pop up a window like this, and the programmer didn't intend it to, and he didn't have time to research the fact that there's two different modes that you can build Windows software in, and one of them doesn't show this. They just don't have time to find out that detail. Um, they'll just leave this here, and a lot of times the solution that they'll come up with is to tell this window to minimize itself automatically after it opens, and that's their workaround. So it's there, but no one's looking at it. Uh, that's a that's a common workaround. If you go to any small business that's got in-house software or custom software or even freeware that they downloaded from the net, uh, that's written in kind of an older style with especially like Visual Basic stuff. Well, that's a really common issue. Are things that rely on batch files, because as nice, comparatively nice as PowerShell is, the signature schemes for PowerShell is just like a nightmare. Um, so it's very hard to write PowerShell scripts and pass them around and have users freely use them and get any value out of that on their system, unless you're in an administered environment where you can, you know, provide, you know, uh, provide some verification of the origin, the provenance of the script. Um, and in those environments where you have a business that they have like a large Windows infrastructure, they have Active Directory kind of telling the client stations, what's what, uh, and what they should be paying attention to, or what's, who owns what key and so on. In those environments, you're still going to find tons of utility software that's very useful, critical for getting work done, but it's just ugly. It's like horrible. Weird pastel buttons and like everything's these funky colors and like all the, the inside of the application totally clashes with everything else on the system. Just weird stuff. But again, Windows users, it's like invisible uh, when they're trying to get work done because it doesn't really matter to them how pretty it is. What matters is that when they type in a customer name in the thing, the customer's contract data shows up or whatever the problem is that software solves for them. So anyway, this is annoying. Um, this is okay, but that's because I was able to manage this field completely myself. Uh, and the shutdown time is kind of annoying. If this just went off like instantly, then that window wouldn't matter as much, right? And if it minimized itself by default, it'd be less of an issue. Better yet, though, we shouldn't even have this because the second I close that, this runtime can be shutting down in the background and users wouldn't know and they wouldn't care. But having that window open is weird. That is an Erlang build issue, and we'll open this. Oh, hang on just a second. And that little the widget population thing is strange too. Um, so here on Linux the other day I did ZX. I was doing commands like this: ZX run something. On Windows, you have to do .lnk because there's links here are like files. They don't have symlinks the same way that we have in the Unix world. So anyway, zx.lnk, and then we can do run vapor. Uh, yeah, and see that. That's just weird. So that works the way we'd expect. Um, there's another version of the ZX command that's ZXH. On If you're on a Unix system, you don't need the .lnk, of course. ZXH run whatever. What the H stands for is head. So we're going to get an Erlang terminal to open here. The Erlang shell is going to pop open. On Windows, that's actually going to open the kind of nicer shell that's got like readline. and so on. Okay, so Vapor's running now, right? And we've also got the shell started. So we'll run a WX demo, and here, let's get this a little bigger. We'll still see some kind of artifacty stuff that's a little bit strange. Like, look at the D here. That D is going to kind of flicker on and off. And we'll see things populate there before they show up. And we don't have this effect on, I think any other system. None of them show this. I don't know why graphics context takes so long to populate here. That was pretty weird. So things like that, as stuff populates, there's like this side effect of artifacts showing before the whole frame is ready to be shown. And that's, again, it's not a showstopper. It's just a little bit weird. If we run observer, this is the big one that we really need to fix. If we look at the load charts, right, the refreshes are horrible. This has got to get taken care of. I don't know what to do to take care of it, because I don't actually know why this is not smooth here. But these are, like, this is a significant issue that should not exist. Everything looks good and works fine, but we've got flickering refreshes. Something about refreshes or updates that are just slow enough to be visible, and we seem powerless to prevent them. I don't know why. So that's kind of the main ugliness that happens on Windows is, I mentioned that development's kind of hard on Windows because we don't have a really smooth command line experience. I mentioned that the other day in the other video. This is part of it. Just running Erlang's a little bit slower is part of it. Program paths are kind of weird. Everything's just a little bit different, a little bit strange. For an end user though, let's say you write a business application they need to run, and it's up here. You write a game or whatever you write. Anybody on Windows can run an Erlang application now in a simple way. It's just a little bit ugly and awkward. If it's necessary software that they have to use, I've got a couple of programs out that are written for customers that are critical for their business, and most of those guys are on OS 10. They don't feel any of this. They just click a thing and it works, and they don't even care. They don't even know it's in Erlang. They have no idea. They don't care. It does what they need. The Windows users, though, see this stuff, and it's just strange. For those users, they don't actually use Vapor. There's just an icon launcher per application, and it's actually running the same way everything else does. It's an icon that shortcuts Vapor. Instead of picking a thing from Vapor, it's just telling ZX run whatever itself, and those are just quickly launchers. Which, it all works the same way. It's easy to spit out an icon like that for Windows. But that stupid screen opens up, which is weird. And then sometimes, if it's a complex screen that has to be shown, you'll get like a little fluttery thing there. And people are super forgiving of like web applications that are clunky and weird and slow, but native desktop applications should be snappy. So I don't know how to fix that. The kind of loading speed issues, and it's probably just a WX binding thing that wouldn't be too hard to solve if we focused on it. I don't know how to solve the speed issues. I don't think the speed issues are really on the client side. They're really not that big of a deal. And there's the new just-in-time thing happening. in the Erlang runtime now. So who knows where that's going to go? And computers are just getting faster every day. I'm not too worried about speed. Startup speed is a little bit frustrating, but runtime speed, it's not. That's not really a big deal. Um, that terminal window popping up is kind of frustrating. Uh, you know, that's those kind of things. But the biggest one is that refresh rate. When we run Observer and we see that, uh, that flickering happening, that's no good. That means that any graphing application that I write that uses the same technique that um, Observer uses to show live graph updates like that is going to have this flicker, and we can't have that. Um, Maybe there's a workaround. There probably is. There's probably some way to keep that buffer there, write to a new buffer, and then basically kind of blit technique. There's probably a way to do that. I haven't looked into the library deeply enough to see. Um, and the glaring thing that we're missing in the Erlang world, which I think is now probably time to fix, is we don't have audio video libraries. Um, we need library bindings that are cross-platform to get sound and to deal with video, like to create video frames and run video in there. Uh, if I mean, in part, we write streaming servers in Erlang all the time. Like VoIP is dominated by Erlang on the back end. I'm pretty much powerless to write a cross-platform VoIP application in Erlang right now, which that's a silly situation. I can write a chat application, and I've written a lot of those uh, for like, you know, in-company chat and whatever. But we can't do a VoIP plugin because we don't have video libraries and we don't have audio libraries, um, even though the servers are all written in Erlang. So that's kind of strange. Um, with the just-in-time compiler thing coming around, uh, it may also be time to looking at getting bindings from Erlang to Vulkan that work cross-platform so that we have. I mean, OpenGL is good, uh, but of course you can do great stuff with it. But um, there's more things coming along now with AMD aiming at pushing like it looks like their goal is to push 1,000 core desktops as fast as they can get there. So it seems like that's the new uh, Moore's law, right? Is instead of saying how many transistors are on a chip, it's going to be how many cores are on how many cores per system in whatever configuration, if that's per wafer per chip or whatever. But the number instead of numbers of transistors multiplying, it's and then it was clock speed. I think we've tapped out on clock speed and we've minimized things as much as we can. Now it's proliferation of cores. Once once we have so many cores that people don't know what to do with all that number of cores, the next race is probably going to be, you know, bus parallelization for memory channels, and then cache sharing strategies among cores and things like that. Of course, all this is very complex, even at the hardware level, and bringing it up to the software level. Um, Trying to write things in C++ is not going to cut it anymore. Erlang is like accidentally very well positioned to take, you know, to take full advantage of these enormously powerful desktop systems that everyone's got. Uh, and they're only getting more powerful. They're getting more, the amount of computing power at the edges of the network are the amount of just total computing power at the edge is increasing exponentially faster than you could ever increase a centralized data center. The amount of compute power, the sheer number of thunks that you have in AWS is never going to match how much you've got sitting around your house. Because you might have 2 or 3 laptops and a couple of cell phones and maybe a computer hooked up to your TV or a desktop workstation or something. Uh, all of those devices are across the next 5 or 10 years, they're going to get a massive shot in the arm in a way that we can't really do in the data center. And the only language structures that can really take advantage of that in a full way is Erlang right now. I mean, there's frameworks that can do that for other languages. Um, they're always a little bit of an ill fit. They're not, the uh, the ability to handle faults when you have thousands of processes running at the same time, um, and scheduling. Scheduling is just a fundamentally hard problem in computing, and the approach that Erlang has taken to it, in to the point that there are language primitives for dealing with that, is fantastic. Go's got some interesting stuff, and Rust has got some really good ideas on it, but um, parallel processing concepts are not quite the same as concurrent processing concepts, uh, where the world is modeled in such a way that you've got concurrent entities that that do things. The way that OOP, the object orientation was sort of sold to people, and then it wound up just being sequential code anyway. Um, Erlang really has these concurrently living things that are in their own contexts, in their own little world, that can even to the they're in their own little world to the point that they can even crash independently. Uh, that model is the right model going forward, um, with these incredibly powerful desktops that are coming around. And it doesn't matter if they're running Windows or Linux or whatever. Um, OS 10. It would be nice if there was one common system, but there isn't. So there is a common runtime that we can use to take full advantage of it. And it already exists, and it's possible right now to write programs uh, for non-technical users. When I say non-technical, I don't mean it's certainly not meant in a bad way. Uh, it's just that not everybody has the time to become a programmer. No, nobody, not nobody, but more than 90% of the population uh, of any first world country doesn't have the time to care about what's going on inside their computer. They don't see it as a computer in the way that a programmer does. They see it as a device that does useful stuff for them, and they want that stuff done, in a simple way. And we can write solutions for their problems that works, and we can use the same language on the client side as we do on the server side. And again, with core proliferation, or with the proliferation of cores, um, that's going to be the right way to do things at some point. Um, so again, we've got some gaps. No audio video libraries. Uh, and then we've got some just deficiencies. We've got things that work, but they don't work really well. They don't work smooth like they should. And I think it's time to focus on that. We've got some time compilers coming out into the runtime. We've got zillions of cores. Everybody's got a huge GPU now. Even like onboard garbage GPUs are monster compared to 10 years ago. So we should take full advantage of these. And that, I started this video out saying this is, a follow up to this is the ZX and Vapor experience of users on Windows. And now I'm kind of ending with like an appeal to improve the Erlang runtime experience on Windows in general, and cross-platform bindings in general, for uh, you know AV and widgets and graphics. Um, but those all, I mean, the way I see this is that's all one related issue. Um, we've got a fantastically powerful tool, uh, and an easy way to deploy code now. So leveraging those all together would be very, very nice. Uh, so anyway, if you're a Windows expert, if like Windows is your home and you've done Windows development, Visual Studio well, kind of the paradigm that's on Windows, because it's very alien to me. Um, I know that there's cool things you can do on Windows. I don't know what they are, and I don't know how to get them done. And trying to do, paid work, keep the bills paid, and all that, especially right now, this year. I mean, man, my company took a huge hit this year. We lost $250,000 on unpaid invoices on delivered work, which crushed us. So trying to keep a handle on things in the real world while uh, trying to kind of push this as as a future path alternative. Um, I just don't have time to read. I know there's information out there. Microsoft has a huge amount of developer information out public that you just read, and I know they've got, um, but there's like open source. I guess there's versions of developer packages that are uh, for open source development that you can get that don't cost anything, and that's great. But the time investment in figuring out how any of that stuff works um, is quite high, and I just don't have time. So not right now anyway. It's not a priority yet. So if you happen to be a Windows guy and or girl or whatever, it's 2020. So if you happen to be a Windows unicorn or a TAC helicopter, uh, and you know, you understand the Windows paradigm, uh, and whatever it is that Microsoft kind of had in mind with like how to make things work, and maybe why the Erlang runtime doesn't work quite the way that we would like here, like popping that window up, or why does WX show that little thing? Because I know if you write a native window WX application in C++ on Windows, that's not an issue. So there's a way around this. We just don't have quite. We're not quite lined up. Our bindings don't quite line up with whatever it is that we need to be lined up with to make WX work the right way on Windows. So anyway, um, no more rambling. I hope this wasn't too annoying to listen to, but it's YouTube. If it was annoying, you could just turn it off. So I guess I don't care. Anyway, thanks for listening to me babble, and I hope that you find this tool useful and interesting, and I hope that it's it's clear that there is a way forward uh, using Erlang both on the client and server side. That there's a really simple way to deploy code now. It's not very pretty yet, but we can make it pretty. I certainly will be working on making it prettier for my part. And we can, man, just think of what you can do with all the power that's coming to these desktops. Um, you know, fully peered. We can, the amount of stuff we can probably get done in just the peering space. P2P, peer-to-peer software paradigm was supposed to like save the world, and then we went to the cloud and centralized everything anyway. Um, that seems far less necessary than it used to, and we've got a very smooth platform to kind of go get back to some of the benefits of peering, um, client to client. So uh, that's all I got. If you're a Windows person that knows the details of this, please let me know. Send me an email, find me in IRC. Uh, I'm on everything. I'm on IRC, Discord, Slack, whatever. Just find me somewhere and let me know if you know the way to kind of sort these issues out. Thank you very much.